Hey friends, Jim here with Science Talk. I want to share this uh, quick little uh, article that appeared on the online publication EOS. Surface temperature sets the pace of sea level rise. Now that may seem like a duh, but in science we actually go and get evidence to back up things. Reigning in global mean sea level rise, that'd be GMSL, from land ice wastage and ocean thermal expansion requires reducing global mean surface temperatures to near pre industrial values. And that means 1750, not 1850, 1880, or how else the IPCC moves things around. So, this figure is the crux of this short little article. I'll get back to it momentarily. I want to share with you what else is said here. Global sea level rise is one of the most insidious consequences of climate change, narrowing the uncertainties of how much and how fast sea level will rise in the years to come has been a major goal of the climate community. Grinstead et al., recent paper this year, and I have looked at the paper there. Take a step forward by bringing together data and models to more tightly constrain the connections between global warming and sea level rise. The authors show that rates of global mean sea level rise due to melting ice sheets, glaciers, and ice caps, and to ocean thermal expansion exhibit linear relationships with global mean surface temperature, meaning that as temperature increases, the melting increases with the sea level rise increases in a linear manner. I'll have more to say that in a bit. Data of the recent past and simulations of the future under a variety of scenarios mostly paint consistent portraits of these transient sea level sensitivities. Yet an important exception is this: the observations suggest that the Antarctic ice sheet may be more sensitive to warming than the models anticipate, meaning that current projections of future global mean sea level rise may be too low. So let's look at this figure here, which is kind of the basis for this quick little article. The relationship between global mean surface temperature, GMST, right? Global mean surface temperature in Kelvin. Okay. Interesting, they got -1 Kelvin. So that's the horizontal axis, global mean surface temperature, and the rate of global mean sea level rise, right? And that is given by the derivative ds dt. And that capital T is an error in this here. Capital T usually means, unless they let's say millimeters per year. So that's the rate of change with respect to time. Because dsdt with the small case t is time, and they're given it in millimeters per year. Because dsdt, t is temperature. So are they relating the change in sea level rise with respect to temperature? That would be a valid measure. Or are they simply looking at it with the change in sea level with respect to time? That's interesting. I think they might be mixing two things here. Well, let's see. Saying surface temperature sets the pace. So I would think that dsd capital T is the intended derivative. So that's what it should be, a capital T here. And then that change in, you can then measure the change in sea level rise with respect to temperature by, what happens, how many millimeters per year. So it looks like they're trying to do two things, two derivatives at the same time. The change in sea level with respect to change in temperature, this respect in sea level with respect to change in time. Okay. Gray circles and black lines, that's these guys here, are estimates of this relationship from past observation. So basically, these would be the means, and these are your standard errors. Say it might be a 95% confidence, and so forth. The scattered dots, that's all this stuff here, are values from model simulations on the different, what's called SSPs, shared socioeconomic pathways. Color identifies the SSP. Solid ellipses encompass the corresponding mean plus and minus one standard deviation. That's in here. Okay. Dash ellipses envelope the mean plus and minus one standard error over 2051 to 2100. So this is projecting into the future. The gray lines are linear fits to the model. Okay. So when they look here at the shared socioeconomic pathways, the 2.6 to 4.5 to 8.5, that's a reference to the RCP, the representative concentration pathways that the IPCC likes to use. So blue is the 2.6, 4.5 is, what's that, orange, and then 8.5, what do we call that, raspberry? Whatever that color is, fuchsia, okay? And then this is based on actual data. So these are projections into the future, and these are actual data. And then mixed in to this scatter splat of the future SSP are some of the actual SSP for which we have data. Kind of a bit messy, if you ask me. But what we see here is we see a clear linear trend of that the sea level rise will be increasing as time progresses. The worst case scenario is, of course, the raspberry one, the 8.5, where we see the highest increase. That's what this is showing. Now, they claim linear relationship, the increase in sea level. When I did my ocean heat content update video, I presented data that indicates that sea level is increasing exponentially and that there was an acceleration in the sea level rise. Various things can bring into play how rapidly, as you warm up the planet exponentially, the melt rate of the glaciers, increases exponentially. Therefore, if those two are increasing exponentially, it would stand to reason that the sea level rise would increase exponentially. And then if you have major calving events where whole chunks of ice break off and drop into the ocean, then it carried away to eventually warmer latitudes, that melts, that will add to the increasing exponentially aspect. So I think once again they're falling into the trap of the IPCC that in assuming linear increases. Things are exponentiating, temperature is exponentiating, increases, melt rates are exponentiatingly increasing. So therefore it's logical to expect sea level rises to increase exponentially, not suddenly become a linear increase. So anyway, the point is we're warming up the planet's surface. We're going to increase the pace of sea level rise. That means sea level will rise more so and more so at an ever faster rate. And I'm contending here that that rate is exponential, not linear. So If you guys are interested, I could do a deep dive into this original paper and show you all their findings, the various contributions from, say, Greenland and Antarctica, etc. But I think this is the general point. Warm up the surface temperature, ultimately leads to more sea level rise. Basically due to melting ice, thermal expansion. Not good news. Talk soon.